displacement. We look at speed, velocity, and acceleration. Now, more importantly, we look at how they are connected. Now, acceleration, how they are connected to each other. And we'll start with the simple case when they are all along a straight line, of an object moving along a straight line. So let's see, we have imagine there is a table, for example, and I have a little ball, okay, a little ball there, and this little ball moves along the table. Alright, now what we have seen before is that some of these are actually vectors. Okay, there's that one, and that one. So these are all vectors, right? These are all vectors. They have a magnitude and a direction, and speed. Let's see that one. Speed is a scalar, meaning it only has a magnitude. It means just a number, but it does not have a direction. Okay, so let's see. So these are vectors. Displacement is a vector, and velocity is also a vector. Now we've also seen how to add vectors by drawing arrows and triangles and parallelogram. Now this time we want to start by developing the relation between these four quantities. So I'm going to start with just simply motion along one direction. So let me think of this as let's say the x-axis, the x direction. So I'm just going to think of motion along a straight line, so it doesn't go up, down, left, right, or in 3D. So therefore it's just one direction. Well, not actually one direction. Therefore there are only two directions. Okay, now the two directions are let's see, let me color. Right, so the two directions are this direction and that direction. That's all. Okay, and I'm going to think of this direction using plus and minus sign. So I'm going to let this direction be a plus, and I'm going to let the opposite direction be a minus. So plus and minus are just one way to tell us the direction. So if I tell you that I'm going to always call the right hand side the plus direction, then next time I talk about plus, you'll know that I'm talking about the right hand side. I can equally well have chosen plus to be on the left. So, but let's see how how we could actually use this sign in a moment. Right. So okay. Now let's look at the ball again. Suppose that this ball moves along this table, and suppose that it is moving to the right with a certain velocity u, well, with a certain velocity speed, okay, say 3 meters per second. All right. No, actually, let's do it this way. Suppose that this ball arrives at this position after some time, after let's say 2 seconds. Okay, after 2 seconds, and suppose that the distance, alright, the distance between these two positions is 6 meters. Okay, now we know from the definition of speed, let me write this down, we know that speed is equal to distance over time. Distance over time. So with this formula we can calculate the speed by substituting 6 meters into distance and 2 seconds into time. Okay, and the answer is 6 over 2 equals to 3, and meters over second we would just write that as meters stroke second, or there's another way to write this, which is quite common in physics. We would call it 3 meter, and then we would write s to the power of minus 1, right? That comes from thinking of m divided by s. So meter second minus 1, right? So that is the speed. Now, but if I'm going to think about velocity now, so velocity, now we know that being a vector, velocity has a direction. So now this ball, this ball here, we know that this ball is moving to the right. So I can say velocity equals to 3 meters per second, and it is to the right. So that gives me, if you like, the complete description of this velocity. But it's a bit cumbersome. We have to write out in words to the right. Now there's another way to do this. Now since I've decided to call the right hand side the positive direction and the left hand side the negative direction, I can use this sign to tell me that direction. So instead of actually writing to the right in words, I can, in this case, I can say plus, now say plus 3 meters per second. So if I see the plus sign, I would know that I'm talking about the right hand side. So that is convenient. I don't actually have to write to the right anymore. Okay, and likewise, if it's going to the left, I'll just write minus 3 meters per second. So now that we have a way to conveniently write down the direction, let's think about how we could actually define acceleration. Now, I'm just going to draw another figure. See, I have just move table, and I have a ball again, this time a yellow ball, okay, rolling along. Alright, and once again I'm going to call the right hand side the positive direction and the left hand side the negative direction. Okay, and this ball, suppose that at first this ball has a speed to the right, okay, of 3 meters per second. Now then, just imagine that maybe someone is pushing it. Okay, so the ball goes faster and faster, and after a few seconds its speed has increased to maybe 9 meters per second. Alright, and let's say this happened in 2 seconds, let's say. So in 2 seconds the ball speed up from 3 meters per second to 9 meters per second. In other words, in everyday words, this ball has accelerated, and we are interested to find the acceleration. Now call the acceleration A. Oh, I'll call it A later. Right, for now what I'm going to do is this. I'm going to write down what is called the definition of acceleration. At least a simple version. I'm going to say that the acceleration is equal to the change in velocity. Okay, there we are. Change in velocity divided by the time taken. I'm going to say that's what it means. So if you compare this with what we know about the formula for velocity, is it would be, well, for speed will be distance over time. Okay, so this is change in velocity over time. Now, so let's see what it means for this situation here, where we have this ball going from 3 meters per second to 9 meters per second in 2 seconds. So to find a change in velocity, now in physics and mathematics, change, this word change in any quantity has a very specific meaning or way to calculate. It always means that you must take the final value minus the initial value, in this case of the velocity, or it could be of other quantities, but it's always final minus initial. Okay, divided by the time taken. Okay, now this gives us something quite clear, quite specific. We are not going to make the mistake of taking 3 minus 9, the 3 and the 9 to get our answer. We have to take 9 minus 3 because 9 is the final velocity. So this is what we are going to do. We are going to take 9 minus the initial 3 meters per second, and we're going to divide by the time taken, which is 2 seconds. So there we are. So we have 9 minus 3, which is 6 over 2, and 6 over 2 is 3. So that's our answer. That's the acceleration. And we always need units in physics. So how are we going to find out this unit? Right, we can actually work them out. Now, velocity, alright, let's go back to here. Velocity has the units of meters per second. Now it's divided by time taken, which is in seconds. So we are talking about meter per second divided by second. So this is equal to meter, if we do the algebra, meter over second squared. Okay, now that's a bit cumbersome to write. We could write it a bit like how we write the units for velocity, meters per, instead of meters per second, we have meters per second squared. Okay, it is also written as it can also be written as right here, or 3 as 3 meters s with a minus 2, so s to the power minus 2, 3 meters per second squared. Now if you think about it, this 3 meters per second squared really means that every second the velocity changes by 3 meters per second. So if you look back at this picture here with the starting ball, at first it's 3 meters per second, so every second this velocity increases by 3 meters per second. Therefore, after 1 second, right, let's say after 1 second the ball reaches somewhere there, and then the speed will have increased by 3 meters per second to 6 meters per second, and after another second the ball comes here and it would increase by another 3 meters per second, okay, to the 9 meters per second.